Good morning, everybody. It's very honor for me to introduce our study for you. My name is Jiwan, a doctoral graduate student attending at Seoul National University of Science and Technology. Now, I will present about a study on the machining conditions of polyurethane materials used for valuable packaging blocks. I'll explain our study as follows. As a 1. Introduction. When transporting valuables such as cultural sets or artwork, it is wisely used a pavement packaging frame block made of polyurethane or polystyrene having the same sculpture surface as the content goods. This is a special packaging process in which the support frame forms smoothly adhered to the content so that valuable can be sufficiently protected from external impact. The support frame surface is made into a suitable shape by giving a correction margin considering the clearance and pressing tolerance based on the shape of the other surface of the valuables, and then is designed so that the surface of the soft material form is machined using NC milling or 4-axis NC rotor, including the machining allowance. At this time, deformation occurs in areas subject to excessive pressure due to poor shape accuracy. If there is a gap with insufficient contact, external vibration cannot be blocked, and damage such as scratch or cracks may occur on the content. When it is machined at NC milling machine, unlike when machining metal or hard materials, it is used a spherical tool with a needle protrusion attached to the cutter blade, and cushion deformation occurs in the workpiece. Regarding this special machining, many researchers show an effort to increase the surface roughness of the workpiece when NC machining of relatively light epoxy foam, and try to determine the machining conditions such as appropriate spindle rotation speed, axial depth of cut, step over, two-pass pattern extremely. Also, some researchers try to evaluate the shock absorption of polyurethane form use a packing support frame material and to reveal the weakness of the pavement support frame. However, there have been no research cases in which the machining conditions have been decided to reduce cushion deformation in consideration of shape precision. When machining soft polyurethane form, and no research have been conducted on the effort of gaps or clamping area on the support frame surface. Therefore, this is investigated the method of determining the NC machining conditions to maintain the shape precision to the surface well. For the polyurethane form, which is most widely used as material for packaging support frame for valuables, and a new method using pouch technique was proposed to find the optimal machining conditions through the simplified experimental model. As a 2. The machining system of packaging support frame. 2.1. Configuration and procedure of machining system. The general automated production process of packaging support frame goes through the process shown in Figure 1. First, a 3D scanner is used to collect 3D scan. 2. The shape of the support frame is designed. At this time, after correcting the curved surfaces, consideration of gaps, elastic margin, and gouging, the two-pass data for NC machining is generated. Then this NC data is input into the NC milling machine. As a last step, assemble the various sub-elements. This polyurethane form has elasticity but has stability in temperature change, chemical stability, shock and external vibration. Table 1 shows comparison for three representative physical properties for two materials of foam, such as polyurethane materials and EVA foam. Figure 2a shows the design sample of the sculpture surface for loading content on a support frame based on the scanned 3D data. At this time, the work of the correcting the sculpture surface is performed is consideration of gaps, tolerance, and margins. When the design process is complete, the curved surface is divided into two upper and lower parts, is shown in figure 2b. And each sculpture surface part goes through the process of calculating the cutting path for and machining is as shown in figure 2c. The tool used here is a special tool in the form of a ball and mill on which has a needle-shaped protrusion. As 2.2, how to search for optimal machining condition of polyurethane foam. When machining polyurethane foam, poor foam accuracy appears unless processing under appropriate machining conditions. So that the determination of machining conditions is a complex problem in the many factors such as feed speed and spindle speed, as well as machining direction, tool action, cutting depth, and spacing between paths must be simultaneously considered. Therefore, in this study, based on the machining conditions that have been accumulated empirically through the expert group, we try to search for more optimized machining conditions in considerations of characteristics that have a major influence on the foam accuracy, and the experimental process to explore these machining conditions. The Tabuchi technique, which can easily evaluate the influence of the each factor, was applied. When the Tabuchi technique is used, the influence of each factor of processing conditions can be expressed in the form of a weight defined by the SN ratio, so that it is possible to find which condition is superior through the SN ratio response table obtained by substituting the result of multiple experiments with foam accuracy as a constraint as a local factor. So if a machining condition corresponding to a small value is found, this becomes the optimal condition in given experimental area. As a 3, optimal machining condition finding experiment. 3.1, equipment setting for machining condition searching experiment. The initial machining condition to search for optimal machining condition are to select the factor that has the greatest influence on the shape of precision and apply experimentally for two factors. The two pass pattern in the inclined direction and step over. The tiny robust, tiny CNC 606 milling machine were used in this experiment as shown in figure 3. And an end mill for foam material manufactured by Kazan Solutions Corporation having table 2. Standard were used. The machining model as shown in figure 4, 3 parts of the inclined model, a gentle slope, a sharp slope, and a corner. In addition, the initial machining conditions were 3 conditions as shown in table 3, which are already empirically applied in actual on-site machining. And as a means to examine the stability of the processing state, it was confirmed the surface roughness measurement. This measurement of 3D shape accuracy takes into account the concentricity evaluation. As shown in Figure 5, two shapes, spherical and cylindrical, were selected as target model. The three machining conditions were set to table 3. And then the change value of the shape accuracy was calculated as the SN ratio by the Takeuchi technique. Meanwhile, in the case of the spherical shape model, two types of the machining are applied. A linear reciprocating pattern draw raster machining and a pattern machining the spherical surface with the end mill descending along the spherical slope draw spiral machining. For this model, both shape, precision, and concentricity were measured and compared. Table 4 shows the result of calculating the machining conditions or shape precision of the experiment as the mesh characteristic value by Takeuchi technique. According to each machining condition, the SN ratio shows a large difference of up to 280%. As a 3.2, optimal machining condition result and discussion. Examine optimal machining condition or result as Table 4. First, for the case for the general slope machining, the spindle speed is condition 2200 RPM in Table 3 is suitable. It can be seen that condition 1, 0.5 mm, is most suitable for the amount of step over condition 1, 1000 mm per minute for the feed speed, and condition 1, x-axis direction for the patterns. In this case, it's sharply inclined part machining. The difference between the maximum and minimum value appears large in most cases. Condition 3, 2200 RPM is suitable for spindle speed, but condition 1, 0.5 mm is most suitable for the amount of step over and feed speed. In addition, the case of corner machining, the difference between the maximum and minimum value is generally large. Condition 3, 2200 RPM is suitable for the spindle speed, but condition 2, 0.6 mm is most suitable for the amount of step over. It is recommended to set the machining condition is consideration of the overall distribution of SN value. Therefore, the environmental condition targeted in this experiment, the spindle speed is set to number 3, 2200 RPM. The feed speed is set to number 2, 1250 mm per minute, and the step over is set to number 1, 0.5 mm. In addition, it can be determined that the pattern 3 condition is an appropriate condition. As a 3.3, measurement result of form accuracy according to machining patterns. The shape accuracy was examined for two models for spherical and cylindrical surface. For the cylindrical surface model, the x-direction machining pattern and the y-direction machining pattern were tested. And for the spherical model, the machining pattern in the linear machining direction and the spiral line linear direction were tested. It is shown in the same error distribution diagram as in Figure 5b to Figure 5c, as the result shown in Table 5. When the spherical surface was processed in vortex linear direction, it was found to be the smallest as 0.1749 mm, indicating that the shape accuracy when machining the spherical surface in the vortex linear direction was the best. In addition, when comparing only the machining of the spherical and cylindrical surface, it shows that the shape accuracy when machining the spherical surface is superior to that of cylindrical surface. It can be said that the smaller change in the better the shape accuracy is. As a 3.4 review of packing performances by vibration test. In order to examine the packaging of performance in experiment was conducted on packaged product and boxes. This experiment was conducted for 4 packaging methods. PU packaging with small gap, which is machined by recommended machining condition in this study. PU foam packing with large gap, which is machined by conventional machining conditions. Cotton felt packing and bubble wrap packing. The vibration test standard related to follow the vibration test methods of KSA ISO 1017. Table 6 is table comparing the amplitude of the input from the vibration tester for its frequency and the amplitude of the packaging content. And in figure 6, the ratio of the amplitude of the packaging content to the amplitude input from the vibration tester draw the amplitude thus obtained is compared and graphed for comparison. The smaller the value, the greater the decrease in the input amplitude. The PU packing support with small gap, which is machined by recommended machining conditions of study, shows very stable. Therefore, it was found that the PU pavement with small gap shows a better amplitude reduction rate than other packaging methods after 20 Hz. As a fourth conclusion, this study explored the machining condition that can maintain the form accuracy of the contact surface so that the paving block can stably support the contact. The optimum machine condition was searched through this analysis result, considering the characteristics that affect the form accuracy as the initial condition and considering the mesh characteristic value of the Taguchi technique. When this result is summarized in the case of the machining a sculpture surface that includes all of the gentle slope, a sharp slope, a corner, the appropriate feed rate is 1,250 millimeters per minute. The appropriate spindle speed is 2,200 RPM, and the appropriate step buffer is 0.5 millimeters. It could be relative that it is excellent to the select diagonal direction for the machining patterns. And the PU packing with small gap, which is machined by recommended machining conditions of this study, showed very stable support performance in all frequency range compared to other paving machines. If you have any question, you could inform to me by using email or SNS tools. I'll answer you as soon as possible. Also, you could refer the detail list and follow reference. Thank you very much for your attention. Bye.